In our previous lessons, we learned about variables and exponents. Today, we are focusing on polynomial. The poly in polynomial means many. We can safely suppose the term polynomial means sum of many terms. Polynomial terms have variables which are raised to a whole number of exponents. There are no square roots of variables, no fractional power, and no variable in the denominator of any fraction. Let me write some examples. 6x is not a polynomial. Because the variable has a negative exponent. One over x to the second power also is not a polynomial, because there can't be any variable in the denominator of any fraction. Also, there can't be square root of variables. This is not a polynomial either. But 4x2 is a polynomial. Four x2 plus 3x minus 7. This is a typical form of writing polynomial. It's called standard form. Let's break down this polynomial. Four x2 plus 3x minus 7. This is a typical polynomial which is called standard form. In this polynomial, you have three terms. Pay attention to the exponents of the terms. The first term has an exponent of 2. The second term has an understood exponent of 1. And the last one doesn't have any variable at all. Polynomials are usually written this way, with the terms written in a decreasing order, with the largest exponent first, then it comes the second largest exponent, the next highest comes next, and so forth, until you get down to the plain number. As we discussed in our lessons on expression, any term that doesn't have a variable on it is called constant term. We call it constant because no matter what value you may put in for the variable x, that constant doesn't change. In this example, no matter what value x will have, 7 always remains 7. In the first term, we have both number and variable. The number is called coefficient. We have two coefficients here. The first term is called leading term. Therefore, the coefficient for the first one is called leading coefficient. The exponent on a term tells you what degree the polynomial has. For instance, in this example, the leading term is a second degree term because the exponent is 2. So the exponent tells you what degree the polynomial is. Let's write another example. This is another polynomial, 2a2 plus 3a minus 5. By looking at this polynomial, we can say that this polynomial is second degree polynomial because it has an exponent of 2 in the leading term. The degree of the exponent in the leading term tells you what degree the whole polynomial has. Let's say we have 5x4 minus 4x3 minus 19x plus 8. This polynomial has 4 terms. By looking at the leading term, you could say that this polynomial is a 4th degree polynomial because the highest exponent of the leading term. Let's say we have 7x5 plus 4x2 plus 2x. In this polynomial, we have 3 terms. The exponent on the variable in leading term shows that this polynomial is a 5th degree polynomial because the exponent is 5. And it's written in a decreasing order. We don't have constant, but we have 7x5, and then the next highest is 4x2, and next is 2x5. By looking at the exponent, you can say the degree of polynomial. But polynomials can be classified both by how many terms they have and by their degrees. First, let us look at the polynomials classification based on the number of terms they have. First, let me make some room here. Polynomial based on number of terms and based on their degree. If a polynomial has only one term, it's called monomial. Let's say we have monomial is a polynomial with only one term, like 2x or 4x2 or z. Then we have binomial. Binomial is a two-term polynomial such as 2x plus y or x2 minus 4. Then we have trinomial, which is a three-term polynomial such as 2x plus y minus 4 or 2x2 plus 3x minus 5. Sometimes we classify polynomial based on their degree. If there is 0 degree, we call it constant. If there is 1 degree, if the polynomial's degree is 1, we call it linear. And if the polynomial is a second degree polynomial, then we call it quadratic. Such as 4x2 or x2 minus 9, for instance, or 3x2. If the polynomial is a third degree polynomial, then we call it cubic. Cubic is second degree polynomial such as 6x3 or 2x3 minus 5x2 plus 5. Then we have quadratic, which is when we have fourth degree polynomial like x4 or 2x4 minus 3x3 plus 2x2. Then we have quintic. Quintic is when we have a fifth degree polynomial like 2x5 or x5 minus 4x3 minus x. All of these are polynomial, but based on degrees they have different names. The first three are the most common one you see. Beyond that, usually you don't see it that often. Now, how to evaluate a polynomial? Let me make some room here and then we can continue with the evaluation of polynomial. Evaluating a polynomial is the same as evaluating anything else. You plug in the given value of x and you simplify the expression. Let's say we have 2x3 minus x2 minus 8x plus 4, given x equals to minus 3. So, when we are plugging in the numbers, we have to watch out for parentheses and negatives because that is the cause of many mistakes we do in our simplifying process. We'll have it equals to 2 minus 3 to the third power minus 3 to the second power minus 8 times minus 3 plus 4. Then we'll have 2 times minus 3 to the third power is minus 27 minus 3 to the second power is 9 Minus 8 times minus 3 will have positive 24 and 4. Then we simplify the expression by doing the multiplication and addition here. 2 times minus 27 is minus 54 minus 9, plus we add these two up and we'll have 28. We add them up and we'll have minus 35, and we are done. Probably the most common things you will do while working with polynomial is combining like terms. To add polynomials, we just drop the parentheses and simplify the expression by combining like terms. Combining like terms is just like any other combining like terms. Terms can be combined only if they have the exact same variable part. For instance, we can combine 5x2 plus 2x. These two cannot be combined. But if we have 5x2 plus 2x2, then we can combine these two terms and have 7x2. Let's say we have 5x plus 6. Can we combine them? No, we cannot. Why? Because it is like saying we can add 5 apples and 6 oranges, and the result would be 11 apples. That is wrong, right? Surely it is a big pile of fruits, but not apples and not oranges. We know that only 5 apples and 6 apples is 11 apples, not 5 apples and 6 oranges, right? The same logic applies to combining like terms. We cannot combine unlike terms because they have different nature. Let me put a guideline here for you so you can determine the unlike or like terms in order to be able to combine them. Let's say we have 4x plus 3. Are these two like term or unlike term? These two are unlike term. These two are unlike term because the second term has no variable in it. Let's say we have 4x plus 3y. Are these like term or unlike term? These are unlike term. They both have variables, but they have different variables. The variables doesn't match in each term. Let's say we have 4x plus 3x2. Are these two terms like term or unlike terms? These are unlike terms. The second term has the same variable as the first one, but the degree is different, so they are unlike terms. What about 4x plus 3x? These two are like terms because they have matching variables and matching degrees. So whenever we have matching variables and matching degrees, then we can say they are like terms. So this is a guideline you can always use and determine your like terms or unlike terms in order to be able to combine them. Now, let's see how best we can simplify a polynomial. For your practice at home, I'm going to put some polynomials here to be evaluated. So let's say we have 25 minus x plus 3 minus x to the second power. 5x2 times minus 2x3 minus 3x times 4x squared minus x plus 10. 2x2 plus 6x plus 5 plus 3x2 minus 2x minus 1. 6x squared plus 10x minus 7 plus 2x squared plus 4x minus 3. So try to evaluate these polynomials at home, and I guess we are done with this session.